We're going to analyze a piecewise defined function by answering a series of questions. We have that f of x equals 2x if x is not equal to 0, and f of x equals 1 if x equals 0. Now the first thing that we want to do here is determine the domain of this function. That is, we want to determine the set of all x for which the function is defined. This function is defined for all reals not equal to 0 in this equation, and it's defined for x equals 0 in this equation. Therefore, the domain of this piecewise defined function is the set of all real numbers. In part B, what we're going to do is identify the intercepts. Well, if we want to know the y-intercept, what we're going to have to do is evaluate the function at 0. What we do is then look in the piecewise defined equations to find the rule for when x equals 0. We can see that if x equals 0, the value of the function is 1, so f of 0 equals 1. To find the x-intercept, we need to solve the equation f of x equals 0. If I use this rule on top, I get 2x equals 0, which says x equals 0. But I have a contradiction here because x cannot equal 0 for that rule, so we ignore that result. Next, if we tried to solve f of x equals 0 for the second rule, we would get 1 equals 0, and of course that's also a contradiction. For that reason, this function has no x-intercepts. Now what we're going to do is graph the function. To graph the function, what we need to do is graph the line y equals 2x. But at x equals 0, we put a hole in the graph because this rule does not apply when x equals 0. Then we plot a point at 0, 1 corresponding to the second rule. The result that we obtain is as shown on the screen. Here is the graph of the line y equals 2x with a hole in the graph at the origin, and then there's the point 0, 1 plotted. Finally, from this graph, we want to identify the range of the function. Remember, you can identify the range of a function from its graph by looking to see where the graph exists for its y values. We can see that this graph exists for every y value with the exception of y equals 0. For that reason, the range of this function is the set of all y such that y does not equal 0. Or if you like, using interval notation, we use the interval from -infinity to 0 or 0, infinity, meant to indicate that the range is a set of all real numbers with the exception of 0.